graph of y equals fx is shown below, and then the dotted line, we need to manipulate the green draggable points to obtain the graph of this transformation. So let's start with this minus 3 on the outside. The number that's way off to the side, that's not touching anything else, that's a vertical shift. And minus 3 means we go down 3 coordinates. So I'm taking this change in direction here, like this vertex, and I moved it down 3 because of the minus 3. If it was plus 3, I'd move it up 3. And then let's take care of the horizontal shift next. If you're taking the x variable and you're adding 4, that's actually moving it 4 spaces to the left. So that's where we should be. And then if you're multiplying it by 3, then that's making us climb at a faster and faster rate vertically. So to make that happen here, first, let's just confirm we did a vertical shift down 3. Move that vertex down 3. We did a horizontal shift, we moved 4 units to the left. And now to take care of this 3, let's think about one of the points in our original dotted line. 1, 1 was one of our points. If you go 1 to the right, you should be 1 up. But now that we're multiplying it by 3, you should be going 1 to the right and times 3 up. So we should be 3 units above. So from this new vertex, go 1 to the right, I should be 3 dots above, 3 points above. Okay, and if that's right, we should be able to plug in negative 4 into our function and get out negative 3. Oh, sorry, but we don't know the function, so I think that's all we can do. If you were to plug in negative 4, it's if you were to plug in 0 into the function, but since we don't know what f of x is, we can't use that to confirm. But yeah, if you use those steps, make the vertical shift, make the horizontal shift, and then take care of that coefficient out front. That either makes it climb faster and faster, or that makes it flatten out and get wider like this. If it's between 0 and 1, it makes the function get wider. But we'll do an example like one of those. Okay, here's another one. Okay, let's do the same thing. Let's do the vertical shift. So the dotted line's the original graph. That means our new graph is 1 above. So I took that corner and I moved it 1 up because of this plus 1 on the outside. And now the minus 1 is, actually this one's a bit tough. Let me get a whiteboard. Okay, before you do a horizontal shift, if there's a number multiplying to x, you've got to factor out that number. So if I factor out 1/3, in parentheses I have x minus 3. Right, so the coefficient x needs to be factored out of both these terms. So in order to make that happen, I put a parentheses, I put an x. If you distribute the 1/3, it gives us 1/3 x, just like it's supposed to. And I chose a 3 over here. That way, if I distribute 1/3, multiply it to 3, it still gives me that minus 1. So that's tricky. If you have a coefficient of x, you've got to factor it out first. And now we know our horizontal shift is 3 to the right. Oh, and I should emphasize that too. It's 3 to the right. The horizontal shift is a little backwards in our mind. If it says x minus 3, that means you actually go 3 to the right. A lot of students think it's 3 to the left because minus, subtracting something, we usually go to the left. But with the horizontal shift, it's a little backwards. You got to go 3 to the right. Okay, what else are we missing? The 1/3, we factored it out. Now remember, a 1/3, like we talked about in the last example, if you have y equals x squared, we know that graph looks like this, something like that. If you have y equals y equals 1/3 x squared, that 1/3 is causing us to flatten out. It takes longer to reach those heights because we're multiplying every x value by 1/3 before we square it. Okay, and then this isn't for this problem, but if you multiply a coefficient that's bigger than 1, then it's like the last example we just did. It constricts it on the x-axis. It stretches it on the y-axis. It's going up at a faster and faster rate. Okay, so for this one, we got to deal with 1/3. We know it's going to flatten out something like this. So to find out exactly how flat it is, let's go back to the original graph. If you go 1 unit to the right, you're supposed to go 1 unit up. So because the 1/3 is multiplying to x, now it's going to take us 1, 2, 3 units to the right before we can go 1 up. Okay, it's 3 units to the right and then 1 up before we start before we get to our next point, because 1/3 is causing us to flatten out. So to take the dotted line, make a new graph, we go 5 units down, 3 to the right, and then it's being multiplied by 1/3, so that should make it flatten out a bit. It takes 1/3 the time to reach our new point. So like this point on the original graph, 1, 1. That's 1 to the right and 1 above. Now it should take us 3 x coordinates to go. We got to go 1, 2, 3 to the right and 1 above before we reach our next value. That's 1 higher. Okay, so instead of being like this, the 1/3 makes us go 3 to the right and 1 up. Let's see if we can do another one in this section. There we go. Okay, so let's put it right on top of the original function. Our -4 means we go down 4 units. And now the negative x minus 5, we have to factor that a bit because x has to be just plain old x. If you factor out a negative sign, now we have just x, and now we can tell the horizontal shift is 5 units to the left. So this dot, we went 4 down and 5 units to the left. And now we also have to deal with this negative sign that's multiplying to x. Okay, that's going to reflect it, make it go in the opposite direction about the y-axis. So instead of being at -2, -1, which is 1, 2, 3, it's 3 to the right, 3 above. Now we're going to go 1, 2, 3 to the left and 3 above. We went the opposite direction on the x-axis. And one more here. So there's our original function. We need to go 4 down, 1 to the left, and then times 2 means we're going to go up at a faster and faster rate. It should be more narrow like this. So in other words, like if you were to take this point 1, 1, and then multiply the y value by 2, it would be 1, 2. So instead of being 1 to the right, 1 above, we're going to be 1 to the right and 2 above because we're multiplying all the y coordinates by 2.